Welcome students. Welcome back for the unit 2. So this is a part 1. So we'll see in the unit 2 we are going to see about procurement and manufacturing. So first we'll start with what is manufacturing related to that and what is quality. So what is quality? Quality is about meeting the needs and expectation of the customer, or it's a future in product or service that provides value for customers. In technical usage, quality can have two meanings. One is the ability to satisfy the needs of the customer and to deliver a product which is free of deficiencies. So there are 8 dimensions for product quality management. So which is used at a strategic level to analyze the quality characteristics. The first one is the performance, followed by the features, reliability, conformance, durability, serviceability, aesthetics, and perceived quality. So over here we'll see the service quality dimensions. So it is basically led to tangibles, reliability and responsiveness, assurance and empathy. So when you see tangible, it is quantifiable, so that service is done in a better management system. So what is the advantage of having a good quality? So advantage of the businesses, it can gain competitive advantage, satisfy the shareholders, increase the business growth, increase customer satisfaction, business strategies, reduce the risk of the business failures, reduce employee turnover, increase employee motivation, and critical learning experiences there. So when you see in the business organization, these are the advantages. When you see with respect to the consumers, it reduces the risk of facing troubles. So as a customer, we risk the facing of troubles or any products without deficiency is much good advantage for us. So it gains value what we the customers really want. Gain fairness to the price they paid. So can increase their satisfaction. Increase their satisfaction can reduce the sub expenses for the consumers. So what is the cost associated with the quality? So when you talk about the quality cost, it has its conformance and non-conformance. So conformance is prevention cost and appraisal cost. Non-conformance, internal failure cost and external failure cost. When you see in the non-conformance, it mainly associated with the design of the product or the service rendered for the product. So when you see the internal failure cost, it goes within the industrial organizations, within the manufacturing unit itself. So when you see the external failure cost, that when a product is not meeting its life expectancy, it means external failure cost over there. So when you talk about manufacturing process and development strategy, it has two main categories. One is strategic goals and tactical goals. So we'll start with the strategic goals. Honesty and integrity in everything you do, and this begins with humility. Develop the manufacturing systems to ensure safety operations in all aspects of the manufacturing systems. So in order to do that, we need to delight the customers, meet all customer requirements 100% of the time. So be good stewards of the company's money, maximize the business profit, identify new opportunities for the business. So these are the generic strategy goals which every management system follows up. Following that will be the tactical goals. When you see tactical goals, there are separate segments over here. So first we'll see operating safely. Safety is a job of the everybody all the time. So be constantly aware of what is going on in the system. Follow the lockout or the tagout systems. Look for loose piping and conduit. And be safety shower should be always done at all accessible times. Awareness of the systems properly, which is grounded. Tripping the hazards. So tripping hazards mainly makes the system foolproof systems over here. When we are going to see whether any hot surface is there and chemical exposure and leaks are there within the systems while operating. So operating safely is one of the key phase in tactical goals. Then following that, eliminate or minimize non-value added steps. When you consider any manufacturing systems, non-value added step is an activity which is going to add cost to the business without adding value to the business. But it is non-negligible. It can be reduced. It cannot be eliminated at an completely. So if you see, the basic non-value added is equipment cleaning, equipment setup, equipment breakdown, maintenance, product testings. But all these activities are necessary, but doesn't add value to our product systems. But it could be reduced down at a greatest time value. Following that is a cycle time. So a cycle time means the entire production time taken for one particular product from the initial stage to the reaching the quality checkup stage. So how to minimize the cycle time? So eliminate or minimize non-value added process like setup time. Find the slowest step and work on it until it's no longer the slowest step. That is, we have to find an optimal value. We cannot go much slower or much faster. We have to find the optimal value which is required for producing a product. So low variability in cycle time requires more starts to ensure customer shipments are not missed. Inventory unneeded finished products adds significant cost. Following that, improve the equipment uptime. So product changeover, keep required tools and materials which is required. Uh, downtime maintenance which has to be planned at every initial stages. Unplanned downtime mission crashes has to be reduced so that we can improve the equipment uptime at a higher rate. So we have to be planning unplanned downtime within the system. This is for preventive maintenance will be taken into account. Following that will be the cost. So track on continual basis. If costs are highly variable, profitably cannot be assured and difficult to reduce the manufacturing cost. So tracking the cost and make sure that it is not at a variable way. So it has to be done on a regular basis. Finding the tactic goals. So find the hidden capital, non-valued steps. So maintenance is an engineer's best friend. So maintenance is a key phase in during the engineering aspect. Always be prepared to do maintenance missions to go down unexpectedly, because we cannot expect this at every turn up. Turn unplanned downtime into planned downtime. So this is one of the preventive actions which can be taken up in a manufacturing aspect. So identify the best practices, find ways to do things quicker while maintaining high levels of safety, reducing the cycle time, improve the equipment uptime. Problems often occur over time. See, when we work on overtime, we have to keep on tracking all the key metrics like capacity utilization, cycle time, product quality, energy use, material utilizations, which are being a critical aspect when you talk about overtimes over here. So graphing these data to identify the trends, and when unplanned breakdown is happening, we can identify from the data. Graphing this data will help us to do that. So these things will be stated from the Pareto chart. Some problems can be caused by seasonal changes also, but it has to be taken into account. And we should not be ignoring logistics, because logistics is one of the effective handling starting materials, work in progress, finished goods, which can affect probability. See, logistics comes at every stage of the process, from the procurement to the raw material stage, formatting from first system to the next system, then going for a quality aspect, then to the warehouse, following with the consumers. So logistics cannot be ignored at all those times. So minimize the work in progress. Work in progress is material where costs have been incurred, but the business cannot realize any revenue from them yet. So this is accomplished by good planning. Work in progress only becomes value to a business when it becomes as a finished goods. So what is the power of capability analysis? So understanding CPK allows for quick identification, classification, and prioritization of problems. So what are the problems actually there in the system will be done. Understanding them is on a key phase over here. Repeatability studies should be done on all process and product measurements. If both capability planning and capability planning factors are low, you have a precision problems. So over here, we have a two set of diagrams which shows that accurate but not precise. That is, it is accurately doing that, but it's not being precise at the moment. Over here, it is precise but not accurate. So the systems has these two states of problems which can be identified through uh, power of capability analysis. So it prioritizes the issues for us. Precision problems must be resolved before accuracy problems. Excessive variability in the incoming material, processing condition, equipment operation, process of product measurement systems in the space and time. So these are the phase where we have to look for the precision problems over here and how it has to be accessed. Accuracy problems are solved by optimization studies using designed experiments, right? So method of steepest assessment experiment, resolution of 4 experiments give you the most information for any money spent. So this is like mostly like having a prior run of the system so that I can correct the accuracy problems over here. Followed by the cost reduction. So elimination or reduction of non-value added operations is mostly important for cost reduction. Finding the hidden capital which is involved, effective use of the operation team, located needed supplies where they are needed, and as we said, constantly track key manufacturing metrics like capability, cycle time, equipment uptime, incoming material, labor, maintenance, engineering, and support. So all these factors has to be taken into account. So following that, we have to consistently track the key manufacturing metrics as we said over here. So it costs 10 times more to solve a problem in manufacturing than in development. So, and it costs 10 times more to solve problems in the development than in the research. So 10 times the 10 times is more than 100% over here. So the earlier problems are identified and resolved, the less it costs the business. When we say identifying the problem and solving the problem, identification of the problem alone consists of 70%, where 30% alone is being sent for the solving the problems. So finally, we are seeing the competitive dimension in manufacturing. So as we discussed over here, cost, product quality and reliability, delivery speed, delivery reliability, volume flexibility, flexibility and new product introduction speed. So other product specific criteria, technical support, after sales support has to be taken into account. So this is a one of the dimensions, competitive dimension in manufacturing. So in this video, we are seeing the aspect of manufacturing and quality aspect with respect to procurement. So thank you. Following that will be the part 2 over in the unit. Thank you.